Today we will identify, evaluate, add, and subtract polynomials. We will also classify polynomials. So monomial is a number, a product of numbers and variables with whole number exponents. So multiplication. A polynomial is a monomial or a sum of monomials. Term, each monomial in a polynomial is a term. And then the degree of a monomial is the sum of the exponents of the variables. Exponents. So here's some examples of what are polynomials and what are not polynomials. So they're being multiplied, they have positive exponents, we're adding or subtracting different monomials. These are not polynomials, so you cannot have x or a variable as an exponent, no absolute values, no negative exponents. And remember that if the exponent is on the bottom of a fraction, it's a negative exponent, so that cannot be a polynomial. No square roots, and it needs to be a whole number, not a fraction. All right, so x squared, what is the degree? Well, we're adding the exponents of the variables. So we have a 2 here, so it's a degree of 2. 8, there is no variable, so we're going to have a degree of 0. 12 times x times y to the 5th. Well, we have a 5 as the exponent here, and then we know if we don't see an exponent, the exponent is actually 1. So 1 plus 5 is 6. And then we have 5 times x cubed times y times z to the 4th. So 3 plus 1 is 4, plus 4 is 8. Some more vocabulary. Degree of a polynomial is given by the term with the highest degree. Leading coefficient. When a polynomial is in standard form, which means it's listed from highest degree to lowest degree, then it's the first coefficient. So here's an example here because it's a little bit easier to understand when you're looking at an example. So we have f of x equals 4x cubed plus 3x squared plus 2x plus 1. So this is in standard form already because we have the highest degree first and then it goes down to the lowest degree. So the degree of the highest degree is 3, so the degree of the polynomial is 3, and the leading coefficient is that first number there, which is 4. If there was no number there and it was just x cubed, then the leading coefficient would be 1, so don't forget about that. Even more vocabulary. A binomial is a polynomial that has 2 terms, like this linear equation here. This would be a binomial. A trinomial is a polynomial with 3 terms. So this quadratic here, it has 1 term, 2 terms, 3 terms. So this would be a trinomial right here. So we're classifying polynomials by degrees. A constant doesn't have any variables and it has a degree of 0. Linear is 1 degree because we have x to the first power here. X squared, a degree of 2, that'd be quadratic. Cubic has a degree of 3, quartic 4, and quintic 5. So you can, as always, pause the YouTube videos to spend more time taking notes and then press play when you're ready to move on. All right, so here's an example of a polynomial, and we're asked for the degree, the leading coefficient, the number of terms, and what to name it. But before we do all of that, we really need to get it in standard form. Standard form. All right. So standard form, remember, has the highest degree. See if I can spell. the highest degree down to the lowest degree. So the 5 has a degree of 0, negative 2x squared has a degree of 2, and 3x has a degree of 1. So to get it to standard form, we need the highest degree first, so negative 2x squared. Then go on down the line. 3x is a higher degree than 5. So now we have it in standard form. So that's done. Now we need the degree, which we already figured out that the highest term has a degree of 2, so it's degree of 2. The leading coefficient is the number at the very beginning once it's in standard form. So that's negative 2. Number of terms, let's count them out. 1, 2, 3. 3 terms. So now what do we name this? Well, it's a degree of 2, so that's quadratic. And there are 3 terms, so it's a trinomial. So it's a quadratic trinomial. Now we're going to add and subtract polynomials. So there's a couple of ways we can do this. So here's our first example. 2x squared plus 5x cubed plus 2 plus 9x minus 5 plus x squared. So some of you will just notice here, well, I've got this 5x cubed. So, okay, 5x cubed. Then I have 2x squared and x squared. That's 3x squared. I have a 9x over here. And then I have a couple constants. All right. And I've got my answer. But for some of us, it's not so easy to pair it up. So what I would do is put this in standard form over here. So 5x cubed plus 2x squared. Leave a space for x's. And then add a 2. So all I did was rearrange this polynomial here. Put it in standard form, but left a space because we don't have any just x's. And then I'm going to line these up here. I have x squared plus 9x minus 5. Then I'm going to add them this way. 2x squared plus x squared is 3x squared plus 9x minus 3. I get the same answer. It's just that one of these methods is going to be easier for you. So you pick which method is easier for you. Now let's look at subtracting. All right, the big thing with subtracting is that you need to distribute that negative across. So this positive 5x squared is now a negative 5x squared. This positive 2x is now a negative 2x. And this negative 1 is now a positive 1. So we can do the same thing here. We can do the 4x cubed minus 5x squared, skip a space for x's, plus 11. And then now we have negative 5x squared minus 2x plus 1. So we have 4x cubed, 10x squared, 2x, 12. So there's our answer, but again, you could just be like, okay, 4x cubed, that's all my x cubes. Negative 5, that's negative 10x squared. Got rid of my x squareds. Minus 2x, got rid of my x's. plus 12. I got rid of my constants and I have nothing left over. So again, now we have the same answers. We just went about it two separate methods. So that's what I got for you today. If you'd like some more practice, you can go to IXL Algebra 2, Section L, and then 1 and 2 are the ones that you'll want to work on for what we did today. See you in Zoom.